Geothermal power plants, ensuring environmental sustainability. Geothermal power plants, ensuring environmental sustainability. Introduction. In our quest for sustainable and clean energy sources, geothermal power plants have emerged as a promising solution. Unlike fossil fuels, geothermal energy harnesses the Earth's natural heat to generate air. 8. Electricity without harmful emissions. This article delves into the concept of geothermal power plants and examines how they contribute to environmental sustainability. Understanding geothermal power plants. Geothermal power plants tap into the Earth's internal heat to generate electricity. The Earth's core, composed mainly of molten rock and metals, emits vast amounts of heat. This heat gradually moves towards the surface, creating geothermal reservoirs that can be harnessed for power generation. The process begins with locating suitable geothermal reservoirs. These are typically found near tectonic plate boundaries or areas with active volcanoes. Once a reservoir is identified, a well is dry. Pulled into the geothermal source, allowing the hot water or steam to be brought to the surface. The hot water or steam extracted from the reservoir is then transferred to a geothermal power plant. Here, the heat from the fluid is used to produce steam, which drives a turbine connected to a generator. Ultimately generating electricity. The used fluid is then re-injected back into the reservoir, completing the sustainable cycle. Environmental benefits of geothermal power. 1. Low carbon footprint. Geothermal power plants produce minimal carbon emissions. Unlike coal or gas-fired power plants, geothermal plants do not burn fossil fuels. As a result, the release of greenhouse gases into the atmosphere is significantly reduced, minimizing the contribution to climate change. 2. Renewable and sustainable. Geothermal energy is considered renewable because it is derived from an inexhaustible heat source within the Earth. The continuous regeneration of heat within the Earth's core ensures a reliable supply of energy for generations to come. Geothermal power plants have a long operational life, thereby making them economically and environmentally sustainable. 3. Land conservation. Geothermal power plants require relatively small land areas compared to conventional power plants. This is because they utilize the Earth's natural heat, eliminating the need for large coal storage yards or ash disposal sites. Consequently, geothermal power plants help conserve land resources and minimize deforestation for energy production. 4. Reduced water consumption. Unlike fossil fuel power plants, geothermal power plants consume minimal amounts of water. Traditional power plants rely heavily on water for cooling purposes, consuming vast quantities of this valuable resource. Geothermal plants, on the other hand, recycle the extracted fluid, minimizing water consumption and reducing the strain on local water sources. 5. Energy security. Geothermal energy provides countries with a reliable and secure energy source. Unlike fossil fuels, which are susceptible to price fluctuations and geopolitical conflicts, geothermal energy is domestically available and not subject to the uncertainties of international markets. This strengthens a country's energy security and reduces its reliance on imported energy sources. Challenges and mitigation. While geothermal power plants offer significant environmental benefits, they are not without challenges. The three main challenges are: 1. Limited geographical availability. Geothermal power plants can be operational only in specific locations with suitable geothermal resources. This limits their widespread adoption compared to other renewable energy sources like wind or solar power. However, ongoing advancements in drilling techniques and exploration technologies may expand geothermal potential in the future. 2. High initial costs. Developing geothermal power plants involves substantial upfront investment. Drilling deep wells and constructing necessary infrastructure make geothermal projects capital-intensive. 5. However, over the plant's lifetime, operating costs become relatively low, providing cost competitiveness in the long run. 3. Potential environmental impacts. While geothermal plants have a smaller environmental footprint compared to traditional power plants, they can still cause localized environmental impacts. These include the potential release of trace amounts of harmful gases and fluids during geothermal fluid extraction and the creation of seismic activity in certain cases. Measures such as careful site select, proper disposal of extracted fluids, and monitoring of seismic activity can help minimize these impacts. Future prospects. Advancements in geothermal technology. Geothermal power plants have made substantial progress in recent years, but there is still untapped potential to harness this renewable energy source. Ongoing research and development efforts are used on improving drilling techniques, exploring new geothermal reservoirs, and increasing efficiency in power generation. 1. Enhanced geothermal systems, EGS. EGS technology aims to expand the geographical availability of geothermal power plants. By creating engineered geothermal reservoirs, EGS can enable power generation tie-in in areas previously deemed unsuitable. The process involves injecting water into hot, dry rocks deep underground to stimulate fractures that allow the circulation of geothermal fluid. Although still in the experimental stage, EGS holds promise for unlocking the vast geothermal potential worldwide. 2. Thermal energy storage. Geothermal power plants can incorporate thermal energy storage systems to offset intermittent power generation. By using excess electricity during periods of low demand to heat rocks or store hot water underground, geothermal power plants can provide a stable and reliable energy supply when demand is high. This technology helps address the inherent variability of renewable energy sources and enhances the overall grid stability. 3. Geothermal heat pump systems. Geothermal heat pump systems utilize the stable temperature of the Earth's surface to provide heating, cooling, and hot water for residential and commercial buildings. By leveraging the constant underground temperature, these systems can significantly reduce energy consumption and greenhouse gas emissions from traditional heating and cooling methods. Geothermal heat pump installations are increasing globally, offering an efficient and sustainable alternative to conventional HVAC systems. 4. Offshore geothermal development. Traditional geothermal power plants are land-based and require suitable geological conditions. However, recent research is exploring the potential of offshore geothermal energy extraction. By tapping into geothermal reservoirs beneath the ocean floor, offshore geothermal development could offer a significant expansion of geothermal energy resources. This not only increases the available resource but also avoids conflicts associated with land use and environmental concerns. The way forward. To fully unlock the potential of geothermal energy, collaboration between governments, industry, and research institutions is crucial. Continued investment in research and development is needed to improve exploration techniques, enhance drilling technologies, and reduce costs. Additionally, supportive policies and incentives are necessary to encourage the deployment of geothermal power plants on A larger scale. Public awareness and education campaigns can also play a vital role in promoting geothermal energy as a viable and sustainable alternative. Geothermal energy is a type of renewable energy that harnesses heat from within the earth to generate electricity. Geothermal power plants are specifically designed to tap into this heat and convert it into usable energy. Unlike other forms of energy generation, geothermal power plants produce minimal greenhouse gas emissions, making them a sustainable and environmentally friendly option. The process of generating electricity from geothermal energy begins with locating areas where the Earth's heat can be accessed. These areas are typically found near tectonic plate boundaries or regio. NS with active volcanoes. Once a suitable location is identified, a well is drilled into the geothermal source, allowing the hot water or steam to be brought to the surface. The extracted hot water or steam is then transferred to a geothermal power plant, where it is used to produce steam. This steam drives a turbine connected to a generator, which ultimately generates electricity. After the fluid has been used to generate power, it is injected back into the geothermal reservoir, completing the sustainable cycle. Geothermal power plants offer several environmental benefits compared to traditional fossil fuel power plants. Firstly, they have a significantly lower carbon footprint because they do not burn fossil fuels. This means that they do not release large amounts of greenhouse gases into the atmosphere, helping to reduce the impact of climate change.